Okay, this is day 3 vectors to be completed after the virtual vector lab. So you should have already completed the vector lab, and that should have given you some good background in writing vectors in terms of their x and y components, and also writing them in polar notation, which is r, or the length of the resultant, and then theta, the length of the measure of the angle. Now we're going to deal a little bit more with measuring angles. When we are sketching angles, all angles are measured from the positive x-axis. So if I look at what I have here, here's my x-axis, and so when I measure counterclockwise, I have a positive angle measurement. Now the straight angle is 180 degrees, and then I've got an additional 20 degrees, so this angle would have a positive 200 degree measurement. But I could have measured this angle counterclockwise, so I could have gone this way. Now the first quadrant would be a negative 90 degrees, and notice that I have an additional negative 70 degrees there, so I could also write an equivalent measurement for this angle of minus 160 degrees. Negative angles are measured clockwise. So there's two ways that I can represent this angle. Now, this first one we have shown to be 200 degrees, but if I went one complete revolution, which is 360 degrees, and I did a minus 160 degrees, that also yields another way to arrive at a 200 degree angle. Now, coterminal angles are angles that share both sides, meaning they have the same initial and the same terminal angle position. So coterminal angles are really just angles who have more revolutions than another one. For instance, we said this was a 200 degree angle, but if I went around again and then ended up on that side again, that would be a 560 degree angle. So when dealing with vectors, there's going to be times that we have to deal with angles larger than 90 degrees. And that's when we need to deal with a trig chart. For instance, if you're given an angle of 120 degrees, and I'll just draw that up here. So if you have an angle of 120 degrees, that falls in the second quadrant. And the reference triangle is always formed by completing the right triangle with the x-axis. That's critically important. And so when I have a 120 degree angle and I draw the reference triangle, note that the acute angle is actually a 60 degree angle. That's called the reference angle, and that's going to be more important in just a few minutes. So keep in mind that the trig value or ratio of 60 degrees and 120 degrees is going to be the same numeric value, but the sign will be different. And so what I want you to do right now is I want you to pause this presentation, and I want you to use your calculator, and I want you to find the sine of 60 degrees and the sine of 120 degrees, and the cosine of 60 and cosine of 120 degrees, and then again the tangent of 60 and the tangent of 120 degrees. And I want to see which calculator tells you, so write those down. Okay, now that you've done that and you found that we have different signs, we need to discover why this is true. So this goes back to some of our graphing. Whenever we are graphing xy points, there's a combination that will put them in quadrant 1, 2, 3, or 4. And those combinations are given right there. A positive x and a positive y would be in quadrant 1. A negative x and a positive y would be in quadrant 2. A negative x and a negative y is in quadrant 3. And a positive x and a negative y is in quadrant 4. Remember, we number the quadrants 1, 2, 3, and 4. Roman numeral numbers, and we number them starting with the upper right and going counterclockwise around that. Now remember also that our reference angle always refers back to the x-axis. We saw that with our reference triangle just a few minutes ago. So when you're looking at those reference triangles, remember that the hypotenuse, or the R, is always positive, and that's the R of r theta polar notation. And then look at the signs of the sides of the triangle to determine the sign of the trig function. For instance, let's do an example here. If we have an angle in quadrant 3, so here's our angle in quadrant 3. We know in quadrant 3 that the sign of x is negative and that the sign of y is positive. And we know that the length that is 10, which is r, is positive because r is always positive. It's actually a displacement value. So the sign of the angle in this diagram, that angle is 20 degrees, is represented by the opposite side of the hypotenuse side. So the opposite side, the y, is negative and the r is positive. So the sign would be represented, the sign of this angle would be represented by a negative value over a positive value, which has a negative value. So the sign of any angle in quadrant 3 will have a negative value. Likewise, the cosine of this angle, the adjacent over the hypotenuse of my reference angle of 20 degrees, is negative x over r. So a negative over a positive gives us a negative value. That means the cosine of any angle, can't talk today, in quadrant 3 is a negative value. And the tangent, opposite over adjacent, and again we're dealing with our reference angle of 20 degrees. So the opposite side, negative y, the adjacent side, negative x. So negative y over negative x would give us a positive value. So tangent will always be positive in quadrant 3. So to clarify this, we're just going to look at what we call the bow tie chart. So the bow tie chart is an angle theta and a resultant r. And with that angle theta, we can look at the opposite side and the adjacent side and the hypotenuse side, which is always positive. So the sign of this angle theta in quadrant 1 would be the opposite side, which is positive, over the adjacent side, which is positive, which yields a positive value. The cosine would be the adjacent side, which is positive, over the hypotenuse, which is positive, which yields a positive value. And the tangent would be the opposite side, which is positive, over the adjacent side, positive, which yields a positive. Well, that's really no big deal for quadrant 1. That's what we'd expect to get. But let's take a look at quadrant 4. So in quadrant 4, let's look at our reference angle. Remember, our reference angle with our r length is the hypotenuse. That reference angle is always drawn back to the x-axis. That's why it forms a bow tie diagram. So I'm dealing, and I'll change the color here if I can, I'm dealing with this triangle with a reference angle theta that has a length r for the hypotenuse. And notice that the x value is positive and the y value is negative, and the hypotenuse, the r value, is always positive. So if we figure the sign of that angle is equal to the opposite over the hypotenuse. The sign opposite my angle is a negative value. The hypotenuse is a positive value. That yields a negative value for sine, which is what this says. The cosine of that angle is adjacent over hypotenuse. The adjacent side is a positive value. The hypotenuse is a positive value, and a positive divided by a positive is a positive. So cosine will be positive in this quadrant. And then the tangent is opposite over adjacent. So the sign opposite my reference angle is negative, and the sign adjacent is positive, and a negative divided by a positive gives me a negative, which is why tangent is negative in quadrant 4. So this explains why on the previous page, when you plugged sine of 60 into your calculator, you got 0.8660, and sine of 120, you got 0.8660. But when you plugged cosine of 60, you got 0.5, and cosine of 120, you got negative 0.5. That's why the signs are different, is because of the quadrant that the angle is in. So, let's look at an example. For the following, find two angles between 0 and 360 degrees. Determine which quadrants satisfy the sine requirement. Use a calculator to find one angle, and use your knowledge of the required quadrants to find the remaining angle. For example, find the two angles associated with cosine inverse of 0.5299. So cosine inverse of 0.5299. Well, the first thing I do is take the inverse cosine, 0.5299, and I find that is a 58-degree angle. That's our reference angle. And this angle is always drawn to the x-axis. Cosine is positive in quadrants 1 and 4, and you could refer to the bow tie chart. So in quadrant 1, I would have a 58-degree angle. That's my reference angle, and it would look like this. And in quadrant 4, I would have a 58-degree angle. That's my reference angle, drawn to the x-axis. And so in quadrant 4, that would be this angle. See, remember, I always start at the x-axis and go counterclockwise through the quadrants. So that angle is actually 360 degrees minus a 58-degree angle, which is a 302-degree angle. So the angle that is in quadrant 4 would have a measure of 302 degrees. So I would like you to find the two angles associated with the following. So pause this presentation. Make sure you're able to do this too. Don't just go ahead and write the answer down. Pause the presentation and try and figure it out. Okay, quadrant 1 has a 63-degree angle associated with the inverse tangent of 1.9626, and quadrant 3 would also be positive. That's how I know that I need to be in quadrant 3, is because tangent is positive in quadrants 1 and quadrants 3. Tangent is positive in quadrant 1, and tangent is positive in quadrant 3, and this was a positive value. So the angle in quadrant 3 that I would need would have a reference angle of 63 degrees, and I need to find the measure of that angle, which is 180 plus 63 degrees, which is 243 degrees. Okay, the next one, sine and a negative value. Well, the first thing I'm going to do is I'm going to find out that the arc sine of negative 0.5736 is a 35-degree reference angle. So sine is negative in quadrants 3 and quadrants 4. So I know in quadrant 3, here's quadrant 3, I have a 35-degree angle, and so I need to take 35 plus 180 in quadrant 3. That angle would be 215 degrees. And then in quadrant 4, remember bow tie, we always reference the x-axis. So that angle could be found by taking 360 degrees and subtracting 35 degrees. And that is a 325-degree angle. Okay, another way to visualize this is to graphically represent the sine of angles from 0 to 360 degrees. So we could use a length of 10 centimeters placed on the origin and then find the sine if the angle is 1 degree using the sine formula, and then find the sine ratio if the angle is 2 degrees and 3 degrees, etc. And so this applet that you are going to access now, and this link is in Moodle for you, but this applet will actually allow you to see what happens when that angle changes from 1 to 2 to 3 to 4, etc. So follow the instructions. Make sure that the sine radio button is selected before you choose start. Allow the simulation to finish, and then answer the following questions. And then after you've completed that with sine, I want you to answer that with cosine. And that should give you, oops, I'm sorry, I was trying to go there. That should give you an idea of why the sine and cosine values are positive or negative in each of the quadrants as well. So that's it for today. Good luck. Let me know if you have any questions.